Assalamu alaikum and welcome to our channel. I am Dr. Ismail. Today we will talk about a software known as Discovery Studio. When we perform ligand protein docking, we get two types of results. One of the result is your energies and the second result is your dock post. The dock post can be visualized using different software like PyMol or Discovery Studio to generate the publication quality images. These images represent publication quality interactions, that how two different molecules are interacting, what is the distance, what is the RMSD value and what is the bond length. So Discovery Studio perform all these analysis and you can produce a best quality images to be added in your manuscript or in your article or in your thesis. The good thing about Discovery Studio is that is free. You can download it from their official website and you can use it. In this tutorial, we will demonstrate that how you can download, how you can install and how you can use Discovery Studio to produce publication quality images. So let's start. To download the software, go to Google and type download Discovery Studio. From drop down menu, you need to look into this website, which is Dassault Systems. Here it is free download by Ovia Discovery Studio. Click on this studio visualizer. Then you will be promoted to the next page. On this page, provide your professional email like your institution email ID. It is better. Then click on the next button and you will be directed to agree the terms and condition. You need to mention your country. I am here from the Pakistan, and then I accept the agreement. You need to click on it and press submit button. Now you are directed to the next page which say thank you for your interest. Go to the down and you can see the download option, that is for the Windows 64-bit and that is for the Linux 64-bit. I am going to use the Windows. Click on the download button and your download will be started. Download this, start the download, and download is starting. Our download is completed. Then open the download folder and double click on this file. This is BioVia Discovery Studio 2025. Double click on it. It will take few seconds to start. Click on the yes button. Let me minimize it. It is now initializing the setup. Installation is started. Now our installation is completed. Click on the finish button. After installation, go to the start button and type Discovery Studio and you will see Discovery Studio 2025 client and open it. Now it is now starting. This is the first interface of your Discovery Studio. Let me explain it a bit about its functions. First one is the file. You can open a new file or make a new file. The second option is edit. You can make addition. Then view button and chemistry. You can check the hydrogen element, bond, hybridization and charge, etc. This is the structure. You can see their labels, monitor, animate, surface area, etc. You can see the sequence of the gaps. You can make charts. You can find out the script and selection and visualization. Then these tools are for the macromolecule like proteins. Then this window, and this is the help. Below this line you can see there are macromolecule. Before macromolecule you can see build, nucleic acid, edit, and then protein and analyze the protein, analyze sequence and so on. Then second one is the simulation. You can use to run some simulation in it. Then receptor protein interaction, then pharmacophores, then small molecules like your ligands, then X-ray models and the tools. The protein I'm going to use in this demo is 2J0M-PDB. Go to the type in the Google 2J0M space PDB. It will open the PDB database and you can download the protein from this database. This is basically a crystal structure of two protein complex between FERM and kinase domain, a focal adhesion kinase. Go to the download button and download legacy PDB format. The file is, open the file. This is my file 2J0M. I am going to copy this file, and on the desktop I have prepared a folder with the name demo. I have placed this file in this folder. Now come back to the Discovery Studio and go to the file and click on the open. In the open, you can go to the desktop and select your folder in which you have placed the file. In my case, it is demo and it is 2J0M, and then open this file. You can see the protein is here. You can rotate it or you can select it. Right click and then move the cursor so you can rotate the protein. You can see these reds are basically alpha helices and these are basically beta plate sheets, and then you can see there are some red dots. These are basically water molecules, and you can see here is something is gray. This is basically our ligand molecule. Now we want to see what atoms molecule are present in here. You can see here is a small arrow. You can click on this small arrow and you will see there are some protein chain A, protein chain B, then heteromolecule, then water molecule, then these are active site, protein groups and ligand group. You can also open this result in view and then hierarchy, or you can simply press Ctrl H. Let's suppose I click on this, select this one. You can see the protein A is disappear, which means this one is the protein A. Then this is our protein B. Go to the heteromolecule. This is, look on this area. For better, let me hide the protein B. Protein B is hide. You can see in this area, this is the ligand. You can see these are the heteromolecules. Okay, and then you can see these are the red dots. These red dots are basically our water molecules. Okay, so you can have the complete structure sequence from here. Right now I am going to keep it at its original. We come back to the same window and let me explain one more thing. If you can see these are the some more arrows. If you click on it, you will see the specific amino acid. You can select the specific amino acid from here, from the protein chain A. Then these are the protein chain B residues like aspartate 414. You might be confusing that these are two protein B chains. Now look at this. What is this B? This B is basically the heteroatom. This one you will see when you click on it, it's become yellow. And what are these? A and B. You can see into this one. These are basically the water molecules. If you select on this one, all the water molecule in this region are selected. Then these are basically water molecules of the chain B. We don't need water molecule. When you have performed the ligand protein docking, these are already water free. But I have downloaded the protein structure from the database, so it's contain water. We need to remove these water molecules. You can simply click on this one, protein chain A, and you can let me show you how you can deal with the water molecule. Simply let me hide it. Go to the scripts and go to the selection. Here in the selection, you can select the water molecules. You will see all the water molecules in this area become yellow. Yellow means they are selected. Simply press the del button of your keyboard and all these water molecules are gone. And you have noticed the water molecule chain A and B have been also removed from here. Let me repeat it again. I have just pressed Ctrl Z and the previous command has been undone. What I did, I went to the script, selection, select the water molecule and then press the del button of the keyboard and all the water molecules have been removed, and here the water chains of A and B have also been removed. Now what we are going to do the next? The next thing is go to the script and go to the selection. In the selection, select the protein chains. When you select the protein chains, all the protein chains have been selected. Press the del button and you will see the protein chains has been deleted. The only thing left is your ligand. If you want to separate the ligand and save it in a separate file, this is the ligand. Just simply go to the file and click on the save as. From the save as button, go to your desktop folder. In the demo folder, from the demo folder, change the name as ligand and save the format. In which format you want to save it? You want to save it at SD file, you want to save it as mol2 file, or you want to save it as PDB file, protein data bank file. Sometimes different software like Gromix or like Autodoc Vina require the ligand in the PDB format. So you can simply change the file as PDB format from here. I choose the PDB format and ligand and save it. So using Discovery Studio, you can also convert the different type of files of the ligand. You can convert it from PDB to mol2. You can convert from SD to mol2, or you can convert mol to SD, and you can also convert mol or SD into PDB format. You can choose any type you need. Just simply come back to our folder and you can see the ligand.pdb has been generated. Now come back to our original, press Ctrl Z 3 to 4 times and your protein is back. Ctrl Z means whatever the command you have run are undo. Now click on this empty space and again go to the script and go to selection and select from the selection. Now select ligand. When you select the ligand, now you can see the ligand has been highlighted in yellow over here. Now press the del button, the ligand is deleted. Now you can save this protein, save as protein, and you can save the protein in different format. I am going to choose that as PDB format and save it. The protein has been already saved. These are the just options you can utilize for your other analysis. Again press Ctrl Z to look back to your ligand. If you want to delete a selected protein, let's suppose you say you are not interested in protein A. From here select the protein A and simply press the del button, the protein A will be deleted. I am going to press Ctrl Z to undo it. Similarly, you can delete any specific amino acid from here. Simply you can select the amino acid from here and press the del button and that amino acid will be deleted. This is how you can deal with the ligand and protein to save them separately in different formats. Now I have saved the ligand and protein separately. Let's suppose you have performed autodoc vena. From the autodoc vena you have a protein saved as separately and you have ligand saved as separately, but they are docked together and you want to see their interaction. Now what you want to do in this case, go to the file. This is our protein, like you have performed, let's suppose you have performed this in autodoc vena and this is your ligand. Open these together. You can see this is your protein and this is your ligand. This is your ligand. From here you can see these are basically the protein information and this is basically the ligand information. Now we have to merge them together, as your ligand is separate and your protein is separate, but they are docked in some software we suppose. From here click on the ligand. When you click on the ligand, it will become yellow. It means selection. Then right click on it and press on the copy. Click on the copy, which means you have copied the all coordinates of the ligand. Now come back to the protein part, which is ligand free. Right click on this empty space and press on the paste button. You will see the ligand coordinates are here, and if you select over here, the ligand is here. You can use the mouse scroll button to zoom in and zoom out. So now we have merged the ligand and the proteins. Now if you like, let me hide it. This is the first cell is for the protein and this is the ligand. If you want to change the style, you can go to the over here. You will see a display style. You can click on this small arrow and you can change the style from here. Sorry, this is the default. You can choose this one, or you can choose this one, or you can choose this one, or this is by default. There are some other options like over display style. You can change them like stick model, apply, or you can choose ball and stick model and apply. You can choose schedule and ball stick model and apply, and polyhedron apply. This is you can change the color from here, the elemental, parent color, and so on. Similarly, in the atom you have these options. You can change color by carbon only, and you can change the custom color. Then here in the protein, similarly you can change the protein, you can change the graphics, you can change the background, like suppose this is the black color. From the black you can change it to the white. By default we place it as a black. This is your presentation. You can make the quality low, ultra high. You can choose the line, you can choose the orthographic structure, or then do the depth hue. You can change the lighting style. These are the different lighting style. Over here you can view the style. You can see it is a bit dim. Similarly, you can choose the material, that how you can change the ambient, plastic, metallic, clay, rubber. You will see the information over here. This is how you can view your protein. We make it as a default right now. Now I am going to close this one to have a better view, and I will select the display, the graphic as a white, because mostly in publication the white background is preferred. And this is our protein. So this is our protein, and over here this is our ligand. This is our ligand. The next thing, we need to be in the receptor ligand interaction. From the receptor ligand interaction we have multiple things. From here you will need to click on the ligand interactions. When you click on the ligand interaction, you will see this window. What is this? This is your ligand atom, and these are basically amino acids, and these lines shows the interaction. These are different color. This is the green, these are the pink, and these are the yellow. These different lines present different kind of interaction, which we will explain after a bit of time. Now right click on it, on the empty space, and click on the labels and click add. Now you want to add the labels by atom or by amino acid. I am going to choose as amino acid, and from the attributes I am going to use as search in the 3-letter IDs. Three letters IDs. And then apply. You can see the atom are here, but color is not visible. We can change the color from here. You can simply click on this color button, and we are choosing to brown, and click OK, and then apply. The color has been changed, and you can change the font style as for demo I choose 14 and apply. You can see these are the bit higher. We can choose 18 for better visibility. And you can also change the style Arial to any other font style, but I'm not going to choose that, and click on the OK. And you can see these are all the molecules which are interacting, which means valine 436 is interacting over here, and then arginine 550, and then you can see these molecules like leucine 553, isoleucine 428. These are molecules are the basically interacting molecules. So you can also make changes according to your need. Normally the green color shows the hydrogen bond, and this one pink line shows the hydrophobic interaction. Now you are interested to see that what is the bond length between this. To show this, come back on the left menu, and you will find here we have clicked the interaction. In the interaction, show the distance. When you click on this one, you will get the distance. Let me show you. Like this one, this is showing 2.86. It is a size is bit small. I will explain that how you can make this a bit larger. However, it gives you an idea that this is 2.9, 2.87, 3.3, 2.86, and so on. Like the next thing we are going to demonstrate that here we have selected the ligand interaction, then the show the distance, and then here if you are interested that what kind of forces or surface receptor is being occupied, you can choose the aromatic. Click on the aromatic. This is the aromatic surface which is showing the edge. The blue color is edge, and the orange color is phase. You can see the edge and the phase. Similarly, you can select the hydrogen bond. The green color is the acceptor, and the pink color is the donor. Then you can see the charge. This is the charge. The blue is the 0.1 and the red one is the -1. Then hydrophobic interactions, ionization energy, solvent accessible surface area, pink and the blue, and so on. You can contract or expand these by using these two buttons. If you click on the contract, it will make it a small. If you expand, it will make the surface area larger. The other most important and interesting, this is basically the 3D diagram. If you want to see the sequence, right click on the empty space, and over here Ctrl Q, show the sequence. It will show you the sequence of the complete atom. I'm not going to save it. Next thing you can do is right click on the empty space and you will see here is the some text box is appear. You can highlight, you can add text, like if I click on this T1, you can type like my name is Hamad, or you can take ligand protein interactions and click on the OK button. You will see it is appeared over here. You can change it or you can delete it, or if you want to delete it you can simply go again click on the right space, right click and click on the select tool, and you can select and move this one, or you can simply delete it. You can change the color and so on. The other important parameter of this Discovery Studio is 2D diagram. If you click on this 2D diagram, it will show you the 2D interaction. This one was the 3D interaction which you can navigate, and this one is your 2D interaction diagram. And let me adjust it a bit to have a better view. This is our 2D interaction diagram. You can see it is now showing you the information. This is glutamine B500. B mean it's P chain. Glutamine B500B is the chain, and this is the interaction. The green is showing conventional hydrogen bonding and rest of the hydrophobic interaction. You can also change the display. Right click on some empty space and click on the display style. The window will open. Here is the journal. You can change the font style of Calibri. From Calibri to choose any style. You can change the background color. Then you can change the atom. Let me change a bit. Let's suppose we change it to the disk and apply. It is the atom, and let me reduce it to the 2.0, and this is the atom. And you can change the color if you want, like you can change the custom color and change the atom, and you can change it to black. It is converted into the black, or you can change any other color or so on. Then you can go to the residue. In the residue you can choose the disk, or you can choose the ball, or you can choose the plate. I will choose keep it the default, and you can increase or decrease the size. Let it make to the 8.6. The ball size has been increased, or you can place it as a 5 and apply. The ball size is reduced. Let it be the 8 again to have a better view for this tutorial. Then you can see the interaction. You can change the residue color for the interaction. You can change the color over here. You can change any color you like. The other thing is the interaction. Here, what kind of interaction you are interested, like there is a classical bonds, then are non-classical bond. Over here these are classical bond is conventional bonding, and from the non-classical bonding these are carbon hydrogen bond. If you don't want to see it, just uncheck it and apply. It will be disappeared. It will only show you the classical bond. Then you can also change the color of interaction. Here it is green. You can change any other color, and you can also show the distance and apply. Now it is showing you the distance. This is a better view, and click OK. These are the images we normally use in our publication. You can save this image. For saving these images, go to the file and click on the save as. It is now asking it will save in the PNG, JPG and other format. You can also save in the JSON file or SVG if you need. I'm going to change as a normal style, and it changes pick one and save it. Now it is all asking you the pixel. You can change the width and height and unit, whatever you want. Keep the aspect ratio and click on the OK button. Our image has been saved. Now go to our demo folder In this demo folder, you can see our images has been generated. You can use this image in your publication. Come back to our Discovery Studio. Now you can close this image, and if you want to save this 3D interaction, you can simply go to the file and click on the Save As button, and you can save it to any Discovery Studio file, a PDB file, protein data bank file. I'm going to save is the 3D complex. This is basically my complex, and .sdv file, and save it. It will save the original coordinates and file and the working which I have done so far. You can see this complex file has been saved in my folder. You can also save this image as an image file. Go to the file again and go to Save As. In the Save As, from here select the images file, and you can save the current view as a image file. Again, change the width and pixel as you need and click on OK. It will save you the file. Go to our folder, and you can see this is our 3D complex image which we have adjusted for our display. Now if we come back to our original protein structure, if you like, you can also save this structure as file, as save as an image format. The next thing is I want to explain, if you want to see the surface of this whole protein, simply first select the protein. If you want heteroatom, select it. If you don't want heteroatom, remove the heteroatom from here. Right now we have only selected the protein. Go to the structure and the surface and add surface. From the add surface, you will see the multiple options like solvent, soft, VMD, solid, and wire mesh, and by charge. Right now I'm going to add as a solvent and the solid, and click on OK. This is the surface of the complete protein without the atom. You can change it. Go to the structure, surface, add, and I'm going to choose it wire mesh, and OK. It will change it according to the protein. Similarly, if you want to remove it, go to the surface and remove the surface. You can check different options, like here if you select the soft and wire mesh and click on OK, it will add a different kind of poses. This is your aesthetic sense, how you want to present your molecule. Similarly, if I select the VMD and press OK, it will give it a different phase and color. Now I'm going to remove this surface. Remove the surface. I'm also going to include the heteroatom and go to structure, add surface. In here I'm going to choose this one as hydrophobicity, wire and mesh VMD, and click on the OK button. So now it's showing the hydrophobic structure. So this is up to you how you want to color it and present it in your publication. It gives you multiple options to generate the publication quality images. So this is all for today. If you have any question, please ask in the comment section. If you liked our video, please like and subscribe. Thank you so much for watching. Allah Hafiz.